In the yesterday's lecture, what we saw was we had a function, and from the given function, what we formed was a differential equation out of it. We also saw that whatever number of arbitrary constants are there, those has to be equal to the order of differential equation. Okay, so if your function consists of two arbitrary constants, then we differentiate it twice, and after differentiating it twice, we eliminate the arbitrary constant. That is how we form the differential equation. And finding solution of a differential equation is actually other way around. So by other way around, I mean to say that we will be given a differential equation, we need to find solution. Which differential equation we are going to study in this syllabus is ordinary differential equation, ordinary differential equations of order 1 and degree 1. Okay, so every differential equation will look like m x comma y dx plus n of x comma y dy equal to 0. So this type of differential equations, you can see that you can convert it to the form dy by dx is equal to some g of x comma y. So you can always convert it to this form. This type of differential equations we are going to solve in the uh, given syllabus. And the first method that we will see is the variable separable form. This is something that you have even studied in your 12th standard. So I would like to ask you if you remember this thing. Anyone? So you can tell me what do you remember about variable separable form?
Sir, we differentiate in y and x terms. मतलब y एक जगह terms और x के एक जगह terms, and then we integrate on both sides.
Yes, exactly.
Yes, sir.
So what we do is we can convert this. So I will also write down the method over here. So the method is let m x comma y dx plus n x comma y dy is equal to 0 be the given differential equation. Be the given differential equation. So our first step is you separate the variables x and y. So step 1 is separate variables x and y. When you try to separate this variables x and y, this differential equation mxy dx plus nxy dy, this will be converted to the form f of x dx is equal to g of y dy. Okay, if this is possible, then and then only you can go for the variable separable form. This form is called variable separable form. Once we get variable separable form, our next task is integrate on both sides. Integrating both sides, we get solution. Okay, this is the overall procedure. And let me tell you, this is the easiest method to solve the ordinary differential equations of order 1 and degree 1. So whenever you find out any example or you get an example, solve the given ordinary differential equation of order 1 degree 1. Your first preference always has to be the variable separable form. If it is not possible to solve by variable separable, then and then only you go for any other method. Fine. So we'll solve some examples on this, and then we will explore different types which can be converted to variable separable form. Fine. Example number 1. Solve dy by dx plus x square is equal to x square e to the power 3y. So we need to solve this, and that will become dy by dx is equal to x square common in bracket e to the power 3y minus 1. Please check the calculations. And so you can divide by e to the power 3y minus 1. So we get dy upon e to the power 3y minus 1 is equal to x square dx. Once both the variables are separated, this is called the variable separable form. Once you get this, integrate. Remember that integration is done with respect to the variable here. So integration with respect to y and x respectively. Okay, so by respectively, I mean on the left hand side you have variable y. So integration will be with respect to y. And on the right hand side, integration will be with respect to x. Yes, anyone, how to solve the integration?
Sir, hello.
Yes, yes,
In left side, the
yes.
numerator we can write that e to the power 3y minus e to the power 3y plus 1. Then
Oh, okay.
we can separate this. Then we can write that e to the power 3y by e to the power 3y minus 1 into dy
But you
minus.
don't have e to the power 3y in the numerator. No?
No, sir. I can write that e to the power 3y minus e to the power 3y plus 1.
Plus 1 will also have to be adjusted with minus 1.
No, sir. In numerator, we can then e to the power 3y plus e to the power 3y and minus e to the power 3y will be cancelled.
Okay,
And the
I'll write it down here. Just tell me if
e to the power 3y minus e to the power 3y
minus e to the power 3y
plus 1.
plus 1.
Open
But
plus 1 by
no,
e to the power 3y minus 1 into dy.
into dy. Okay. So if you separate this e to the power 3y upon e to the power 3y minus 1
Minus 1
minus
e to the power
integration,
3y minus
this will
dy.
become 1 dy.
Yes.
Okay. Okay, fine. But you will have to adjust this 3, right? Since the
Sir.
derivative of e to the power 3y minus 1 is 3 e to the power minus e to the power 3y. So 1 by 3 log of e to the power 3y minus 1 minus y. Is it correct? Rishikesh, what do you think?
Hello, sir.
Yes, what do you think? It is correct? Okay, fine. It seems correct actually. Just I was worried about this 1 plus 1 is there. Uh, but I don't think it will make any change. It is the same thing. Yes, that's correct. But I'll go by another method. It is correct, okay? I'll tell you.
Like first time in first step we can directly write it as a log e raised to 3y minus 1.
Yes, directly you cannot write. There is no derivative of e to the power 3y minus 1 in the denominator, sorry, numerator. Okay.
Okay.
So to directly write down log, you should have derivative of denominator in the numerator. So another way is that I could adjust terms on the left hand side, and let's see if you can understand this what I'm doing. E to the power minus 3y 1 minus e to the power minus 3y dy is equal to integration of square dx. So what I have done is I have took e to the power 3y common from the denominator. So that will become 1 minus e to the power minus 3y, and that common part in the numerator will be written as e to the power minus 3y. Now I can adjust the derivative of this term 1 minus e to the power minus 3y. The derivative will be actually 3 e to the power minus 3y. So adjust the derivative of denominator in the numerator. So now the integration has to be 1 by 3 log of 1 minus e to the power minus 3y is equal to x cube by 3 plus 3. This will get cancelled out. 3 can be adjusted in this constant, and our final solution is log of 1 minus e to the power minus 3y minus x cube is equal to c.
So it will be actually three times C, right? So it
हाँ,
will be a
मतलब
constant.
it
C
will be
dash.
of course 3 times c. So
3 and 3 C is
instead
the
of
same.
putting that c dash, I simply wrote c because 3 into any constant will again turn out to be a constant. है ना?
New constant. So it will
So
be
I
a new
will
constant.
make c dash. Okay.
Sir, you multiply e to the power minus 3y in numerator, sir. So, where you are dividing that term?
No, I haven't multiplied by e to the power minus 3y. What I have done is, look, I will explore this step a bit to help you understand.
So sir, what he means to say is maybe you divided in numerator and denominator by e raised to 3y. So that also works.
1 upon e to the power dy. Clear up to this?
Yes, sir.
Prasad, I will get you out of the lecture. Please stop that camera or whatever is going on the screen. Okay. Is this clear? So after that, what I can do is I can write the denominator e to the power 3y as e to the power minus 3y. Is the problem clear or not? Utkarsh, I'm asking you since you had a problem with that step.
Yes, sir. Clear.
Okay, I go ahead now. One example you can try on this. So what I can write here is e to the power minus 3y upon 1 minus e to the power minus 3y dy. That's it. Fine. Next one. One example you try this, solve y into dy by dx is equal to under root 1 plus x square plus y square plus x square y square. Let's try this. What is the variable separable form that you get?
Sir, y upon root of 1 plus y square dy equals to root of 1 plus x square dx.
Y
Y upon
upon under root
1 plus y
1
square
plus
into dy equals to root of 1 plus x square into dx.
1 plus x square into d. Exactly. So you just take y square common from the second and third term, sorry, third and fourth term, then 1 plus x square common from whole thing, and you will get 1 plus x square, 1 plus y square. That you just have to adjust. This is variable separable form. Now I will integrate. So integration of y upon square root 1 plus y square dy. So integration into root 1 plus x square dy. So what you can do in the first term is you can adjust a derivative of 1 plus y square is 2y. So you just think of integration of uh, e raised to minus 1 by 2 dt. So that will be t raised to 1 by 2 upon 1 by 2. So that will be 2 times t raised to 1 by 2. So the answer that you will get here is under root of 1 plus y square. The right hand side integration of under root 1 plus x square is, you have changed this formula, x by 2 under root 1 plus x square plus 1 by 2 log of in bracket x plus root 1 plus x square plus c. Look, this plus c is very important to add because that tells you that whatever you are finding, it is a general solution, not a particular solution. Fine. Next, dy by dx solve. Dy by dx is equal to 1 minus x tan of x minus y. Now, who can tell me what we can? How can this be converted to the variable separable form?
Sir, here we need to substitute, means x minus y equals to t, we need to put.
Yes.
So x minus y equals to t, we need to put, I think so.
Yes,
Substitute.
exactly.
Yes.
So
Yes, sir.
there are two types of variable separable form. One in which you can directly separate the variables x and y, and the other type is where you need to make some proper substitution so that differential equation gets converted to the variable separable form. There are two types of substitutions. I will write it down here as a remark. If you want to note it down in your notebook, note it down. The remark is there are two types of substitutions will be helpful. First one is the linear substitution, which means that you can put ax plus by plus c, ax plus by plus c. This you can substitute as say u. First type of substitution. The second one is the quotient substitution, where I can put y by x equal to u or x by y is equal to u. So majorly examples are depending on this two types of substitutions. In this case, I will put x minus y equal to u. Once I put x minus y equal to u, differentiating with respect to x. Note that you also need to separate, replace dy by dx. For that, it is very important that you make the term dy by dx from the substitution. So dy by dx can be substituted as 1 minus du by dx. Make the substitution 1 minus du by dx is equal to 1 minus x into tan u. Once we do the substitution, what we can do here is I can separate the variable. I hope you can go ahead with this now. So 1 this 1 and this 1 will get cancelled out, minus signs will be cancelled out, so du by dx is actually x times tan u. Now this will become du upon tan u is equal to x dx. Now this is variable separable form. Variable separable form. Once we get variable separable form, start integrating. Integration du upon tan u is equal to integration of x dx. So integration 1 upon tan is equal to cot du is equal to integration of x dx. Integration of cot u is
Log of sine.
ln sine of x.
log of sine is equal to x square by 2 plus c. So this is log of sine u. Resubstitute the value of u. Resubstitute u is equal to x minus y. So log of sine x minus y minus x square by 2 equal to c. I hope the idea is clear to everyone.
Yes, sir.
Sir, in the remarks section, what is the second point you've written?
Y by x equal to u or x by y equal to u?
X by y is equal to u.
Yes, u. Next, in the next example, you will understand why. I mean that x by y and y by x equal to u. So solve y into e to the power x by y dx equal to x into e to the power x by y plus y square dy. So anyone, what will be the substitution here?
So put x by y equals to u.
X by y equal to u. X by y equal to u. And look, if you take the derivative at this stage, it would really become difficult for you to take the differentiation here. So I will adjust this term because I want to simplify my derivative thing. Okay, so I will write it as x is equal to y into du and then differentiate with respect to x, or I can differentiate with respect to y. Differentiate with respect to y. So this will be dx by dy is equal to, on the right hand side we will apply uv rule. So u into dy by dx. Oh sorry, d1 actually. Derivative of y with respect to y is 1. So u plus y as it is, derivative of u with respect to x. So I have to replace dx by dy. Okay. So I will make the changes in my differential equation accordingly. Wherever x is there, I will put y into u. So y e to the power u. This dy on the other side will make it dx by dy, which is u plus y into du by dx. On the right hand side, in x is y into u e to the power u plus y square. Look, after the substitution, x is completely removed from my differential equation. Now, one of the y will get cancelled out. Then we can separate the variables e to the power u into u plus e to the power u into y du by dx. The right hand side u e to the power u plus y. This two will get cancelled out. I've done something wrong over dy by du by dy चाहिए ना ये. So sorry about this.
Excuse me, sir.
Yes,
Sir, what you did in left hand side in first step, after y into e raised to power u, after that in bracket.
this differential equation I can write as y e to the power x by y dx by dy is equal to x e to the power x by y plus y square. So I have put the value of dx by dy from this equation. Okay.
Okay, sir. Thank you.
So now from this, I'll write it down here. So e to the power u into y du by dy is equal to y. Again, y can be cancelled out, and what is the variable separable form that you get? E to the power u du is equal to dy. This has to be du. This is variable separable form. Once we get variable separable form, integrating. So integration of e to the power u is e to the power u. Integration of dy is y plus c. Resubstitute the value of u. U is nothing but x by y is equal to y plus c. If you have any problems, you can ask, or I'll go ahead.
So why you differentiate with respect to y?
It's up to me, right? देखो मुझे क्या replace करना है, that is what that is a choice which I have to make. Okay, so I can differentiate here with respect to x also, but if I differentiate with respect to x, what I will get, 1 is equal to dy by dx into u plus y into du by dx. Okay, once I make this kind of derivative, then I will have to separate the things. Once I separate these things, and later what I can do is I will replace dy by dx from this. So whichever is easier for me, that I will substitute. Am I clear? So you have to make the choice which one is easier for you. Either you differentiate with respect to x or you differentiate with respect to y. Am I clear, Utkarsh?
Yes, sir.
So I would like you to solve one example. Now make the proper substitution in this case and then find the solution. Solve x raised to 4 dy by dx plus x cube y minus sec xy equal to 0. Yes, be quick with the solution. What is the substitution? First,
You're putting xy equals to u.
put xy equal to u.
Yes, sir. X y is equal to u.
Utkarsh, by what you will like to take the derivative with respect to x or y?
X.
X. Okay. So x dy by dx plus y is equal to du by dx. Since there is this term dy by dx, we differentiate with respect to x. So x into dy by dx is equal to du by dx minus y. Make the changes accordingly in the differential equation. So x cube in bracket, what you will get, du by dx ah yes, will require a bit of discussion before you start solving. Anyways, let's see who can do it. Yes, anyone? So what we have is x raised to 4 dy by dx plus x cube y minus sec xy equal to 0. Yes, tell me now, have anyone got variable separable form after the substitution? You
Yes,
will
sir.
observe,
X cube by dx equals to sec u by du.
x cube
X cube by dx equals to sec u by du.
by dx is equal to sec cube by du.
du. Yes, sir.
Divided by,
Divided by.
okay, yes, it seems correct. Look, for the others, the reason I stopped there was we should, whenever we make a substitution, you should keep one thing in mind, that one variable should disappear from the equation. Either it has to be x or it has to be y, depending on your substitution. But if I'm substituting, there should be only two variables after the substitution that you always should take care of. So I'll take x cube common. So what I get, x into dy by dx plus y minus sec xy equal to 0. So x cube, x into dy by dx plus y is nothing but du by dx minus sec u equal to 0. Now we can make the variable separate, and what I will get is 1 upon sec is nothing but cos. cos of u du is equal to x raised to minus 3 dx. This is variable separable form. Integrate cos u du is equal to integration x raised to minus 3 dx. Integration of cos u is sin u, which is equal to x raised to minus 3.
1 by 2x square.
minus 2 by x square.
Right, sure.
minus 1 by
X
2x square.
minus 1 by 2x square.
Minus 1 by 2x square plus, so the final solution is sin u plus 1 upon 2x square equal to c. 3 substitute, but u is equal to x into y. The solution is sin of xy plus 1 upon 2x square equal to c. That is fine. Example. I'll give you a easy one. Solve cos of x plus y dy equal to dx. Do it. What is the solution?
Sin in bracket x plus y bracket close minus x is equals to c.
Is anybody else?
Sir, is it y equals to c?
No.
So x minus 10 x plus y by 2 equals to constant.
Sin someone said, but I think it is correct. And what
So will you please show the variable
Sir,
separable
sin,
form?
I said it, sir. Sin x plus y.
du by dx?
Sir, should I repeat?
Yes, tell me.
Sin in bracket x plus y bracket
Hmm.
closed minus x is equals to c.
Okay, we'll solve it. Just a minute. So that will become cos u dy by dx is nothing but du by dx minus 1 equal to 1. So cos u du by
Sir, I
dx.
forgot to take minus 1. Sorry, sir.
So that is cos u du is equal to 1 plus cos u is equal to 2 cos square u by 2 dx. Or you can simply write as 1 plus cos u as it will help for the integration. One plus cos u. So integration cos u upon 1 plus cos u du is equal to integration dx.
Sir, after that, I don't get what to do.
Yes,
After this step, sir, I am
you
stuck. Sir.
okay. You're stuck there.
Yes, sir.
So use the formula for cos u. 1 plus cos u is 2 cos square u by 2, and cos u you can write as cos square u by 2 minus sin square u by 2. Separate,
Okay, sir. Yes, sir.
and that is one way. And any other way, if someone knows, they can do it by that way. So the first term will become cos square u by 2 and cos square u by 2 both will get cancelled out. 1 by 2 will be there, and the second one will become tan square u by 2. Then the task will be integration of tan square u by 2. Okay, so I'll just write down the final solution over here. You can try this later. So the answer is tan of x plus y by q is equal to y plus c.
Yes,
Before
sir.
I before I end up with this lecture, I will just discuss one small example here. Let's see who can uh, tell me what is the solution for this. X into dx plus y into dy upon square plus y square is equal to x into dy plus y into dx upon xy. What is the solution? Look, I will tell you one thing that I'm a person who is regularly monitoring the class. So whoever is giving answers and whoever are active, they will surely get some benefit somewhere. I cannot tell you where actually, but getting in the conversation is a very important thing for you. So yes, tell me, like Prasad Veshu, he got into
So x equal to cos theta, y equal to sin theta. So you can
just
prove
Sir,
x equal to cos theta and y equal to
sir,
sin theta.
1 by 2.
just a minute, one by one.
1 by 2.
1 by 2, sir.
1 by 2 is the solution.
Yes.
Why?
Sir, right side, sir, x dy plus y dx is equal to xy, sir. Numerator side is equal to xy.
Even else,
Sir, x cube plus y cube equals to 0.
x cube plus y cube.
Yes, sir.
No. No one? Think.
Yes, sir. Getting.
If I tell you the solution, you will think that it was so easy. You just need to look at the pattern, what is being followed there.
Minus
Sir,
1 upon 2x equals to 1,
Sir, most
1
of the
upon
terms
2y square plus c.
Just a minute. Just a minute. Yes, Raghav.
So minus 1 upon 2x square equals to 1 upon 2y square plus c.
How you got it?
So most of them are means I cross multiplied.
Any other idea?
So is it right
We
or
can
wrong?
substitute
What you can substitute?
y is equal to ux.
Y is equal to
Ux.
Sir, answer 1 upon 2x square equals to 1 upon 2y square plus c. ऐसा है क्या?
Minus आएगा एक जगह.
Yes, sir, we can get it by directly cross multiplying.
सर
both the
dx और
sides.
dy की टर्म्स को अलग अलग कर दे, मतलब एक साइड dx के पूरे टर्म्स और एक साइड dy के पूरे टर्म्स, तो इजीली सॉल्व हो जा रहा हो.
अच्छा. Okay, that is one way. Of course, you can separate the terms and then you can go ahead. I'm thinking of some smarter way of doing this.
Sir, can we put
We
xy
will divide
equals
by
to
2x.
u and then differentiate with respect to u?
What do you observe? What is in the
Sir,
denominator and what is in the numerator?
excuse me, sir. On
Yes.
the right side, x dy plus y dx is the differentiation of xy.
Yes.
And
And
on the right side, on the left side, we must multiply by 2 and we'll get the differentiation.
so Ayush, tell me now, as you have observed that numerator is the derivative of x square plus y square, and on the right hand side you have derivative of xy, the numerator. So this
The
is
numerator of left hand side is the derivative of xy.
So can we substitute x plus y equals to u square?
no. Okay, let me tell you this. This is the standard.
Xy equals to t.
Okay, wait now. Let me speak. I have put the link for your attendance. Others, I'll give you some time to update it. Others who are interested, you can just look at this now. Okay, if you look at this, x square plus y square, and if you take the derivative of this, you will get 2x dx plus 2y dy. Am I right? Whereas if you take the derivative of xy, you will get x into dy plus y into dx. So on both the sides, it is some kind of variable separable form. It is not actually the variable separable form. So derivative of this is this. Derivative of this is this. So I can write this term as u square, u du. And even this term I can write as v dv.
Very easy, sir.
So that will become 1 by 2 log of x square
U.
plus y square. This is log of xy plus c. So three-step solution. What you need to observe is whatever is given, is it derivative of something? So this method is called the inspection method, and many of the MCQs can be solved orally using this. So wherever you have short time and a difficult example is there, there has to be this kind of technique where you can understand. Okay, fine. Go on, put your attendance. The link is shared.
Sir, it is asking for permission.
What permission?
Yes,
Sir,
sir.
it is disabled now.